Good day. We are looking at balancing chemical equations number 1. You may want to write down notes. Do not hand these in. So we are now applying what we've been doing in some earlier examples and looking at steps, and we're going to start with easy ones and move to more challenging balancing equations, and we'll see how you make out. We're going to do in lots of 5. So we got a group of 5 here. And normally I just do a handful, but since we're in the video age, we might as well attack them all. So I look at this and I see, okay, there's nothing all by itself that I can balance at the end. This is compound and compound, becomes compound and compound, double replacement. And I say, okay, let's go and look at each element. Remember, the arrow is your equal sign. So we have one zinc to the left of the arrow, one zinc to the right. One sulfur to the left of the arrow, one sulfur to the right. So those are balanced. We see one H to the left, two H's to the right, so we've got to balance that. We put a 2 in, and now we have two chlorines, and we could go and check, but it just took a 2, and we're all done. Now in this one, we can see that we can balance the chromium at the end, because it's all by itself, and you can make the same argument for the hydrogen. We can do this and use halves and things, but a lot of people don't like halves. So for this one, we're going to attack it in a slightly different way. What we see is we have 3 chlorines here and 2 hydrogens, and they have to come together in HCl. That means we're going to end up with 6 HCl's, because 3 and 2 fit into that number. If we have 6 hydrogens here, we're going to have a 3. 3 times 2 is 6. And if we have 6 chlorines, we're going to need a 2 here to get the chlorines balanced. So we go boom, boom, there's our 2 and our 3. We end up with 2 chromiums there, and so we put 2 chromiums to the left of the arrow. Now sometimes people like to do this on another sheet of paper, and that way they can scribble notes to themselves if they're having a hard time picturing it. Now some of you might say, hey, I could divide this in half and go 3, 1, 1, and 1.5, and that would indeed be equally correct. One thing I should have pointed out about number 1, if we don't put a number in the blank, it's not 0. It is considered to be a 1. Some smart Alex would go, oh, I'll just balance it, put in 0, 0, 0, 0. But that's wrong, because then you won't even have an equation. Now the next one, we see aluminum by itself, iron by itself. So that means we've got to do the oxygen first. 4 oxygens here, so we'll get a 4 there. 3 oxygens here, we'll put a 3 there. In other words, crisscross, switcheroo. So there's our 4 and our 3. Oxygens are now balanced. Now when I look at this, 4 times 2 is 8, so I'm going to end up with 8 aluminums. 3 times 3 is 9, so I'll end up with 9 irons. And there's my 8 and the 9. And I can go back and double check, all balanced. 2 H's, 2 Brs. This one is incredibly easy. Put a 2 there, all done. Now this one looks quite exotic, and what you may notice is you have an S2O3 here and S4O6, and you say, that's kind of convenient. I know I can balance the iodine at the end, but if I balance out this S4O6 and this, I can put a 2 here. Let's see if that's what comes in. Well, I lied to you. But anyways, I put the 2 in, that gets those things balanced. Now I have 4 sodiums, I have 2 sodiums there, and I end up with 2 sodiums here. This 2 applies to the iodine, and I have my I2 already, 2 iodines. So a 2 and a 2, that one is balanced. Now this one, 4 of the 5 examples are combustions, and if we're burning organic things, I always start by balancing out the carbon, then the hydrogen, and finish with the oxygen because it's by itself. So let's give this a whirl. So 5 carbons became 5 carbons. 12 hydrogens here. Got to remember there's a 2 there, so it's going to be a 6. Now the tricky thing, we go 6 oxygens there. 5 and 2 is 10. There's a plus sign between them. That's 16. So we need a number that multiplied by 2 equals 16. In other words, we need half of 16. And that is 8. That is now balanced. This one, same idea. We have 7 carbons here, so we better put a 7 over there. Now we have 6 hydrogens here, so we need to put a 3 here, because 3 times 2 is 6. Our oxygens are a little trickier here. 3 oxygens there, 7 times 2 is 14. 14 and 3 is 17. Now the difference is we have 2 taken care of here, so 17 oxygens this side. 17 minus 2 is 15. So we need 15 divided by 2. Now in England, often they'd write 15 divided by 2, 15 over 2, and that's okay. But usually you write in 7.5. This next one is a very strange reaction. You might think, oh, that's got to be double replacement, but it is not. It is synthesis. We look at this. We got oxygen in 3 places, so we're going to do some finger cross and ignore the oxygen. We have 4 phosphorus. Now we have 4 phosphorus here. 4 times 3 is 12. So we need a number that's half of 12. And now what we have to do is we balance out the hydrogens. We have to hope the oxygens are balanced. 10 oxygens there plus 6, 16 oxygens. 4 times 4, 16. Next beast, we'll balance oxygen at the end because it's by itself. I look at this, I could start by balancing the sulfurs, but it's tidier if I balance the irons. Remember, if you do this and it doesn't work out, start by balancing something else first. So 2 irons, I'm going to put a 2 right here. Now, by doing that, 2 times 2 is 4, I'm going to put a 4 in front of here. So I know the irons are balanced and the sulfurs are balanced. 4 times 2 is 8, 8 plus 3 is 11. I need half of 11. And that's 5.5. Next one, I leave oxygen to the end. Now I could do things with halves and whatnot, and we'll see what we get up to. But I do see I have a 3 here and a 2 there. So that kind of gives me a clue. I'll probably put a 2 here and a 3 there. And now I know my hydrogens are balanced, 3 and 2. I've messed up my nitrogens, 2 nitrogens, so I better balance with 2 nitrogens over here. And then I go 3 oxygens plus 2 oxygens is 5. And I need half of 5. So I have 2.5, 2.5. And our last examples, they look brutal, but of course they can't be. It's chemistry, you gotta be able to breeze. So we look at this, double replacement, nothing by itself. So we gotta start somewhere. So I'm gonna start with the iron. I have 2 irons here. And so I'm going to end up with 2 irons there. And on this side, I see, okay, 2 times 3, that looks like 6. And so 3 times 2 is 6. I better get a 6 on the side, right side. And what have we done? Well, let's double check. We had 2 irons, we balanced those out. We had 3 carbons here, so now we have 3 carbons there. 6 sodiums, 6 sodiums, 6 chlorines, 6 chlorines. And what we see is 3 times 3 is 9 oxygens, and 3 times 3 is 9 oxygens. Each element is balanced. This one's a real dog's breakfast. We have hydrogen in 1, 2, 3, 4 places, so we know we'll leave hydrogen until later. I look at the bariums, they're balanced. I look at the nitrogens, they're balanced. I look at the chlorines, oh, 1 there, 2 there, they're not. So I'm going to balance the chlorines. And I do that by putting a 2 right here. Now the chlorines are balanced, but I've messed up the nitrogens. 2 there, so I got to put a 2 here. So now I have 2 nitrogens. And I'm checking things out here. Let's see, how many oxygens? 2 oxygens there, only 1 oxygen here. So I put a 2 there. And the oxygens are balanced. Now I've got to cross my fingers and hope that the hydrogens are balanced. 2 times 4 is 8. And then 2 more is 10. So we've got to remember the number 10. Remember that when I point at you, 10. So here's 10 hydrogens. No hydrogens there. 2 times 3 is 6. 2 times 2 is 4. 6 plus 4 is 10. I just pointed at you, you yell out 10. And now we know our hydrogens are all balanced. Next one is neutralization. There's our base. There's our acid. And in this case, it's fairly straightforward. I see I have 3 calciums there. So I know I'm going to have to put a 3 here to balance that out. I have 2 phosphorus here, so I'm going to have to put a 2 in there. So that's what I do. So I balanced out the calcium, now I balanced out the phosphorus. Now hydrogen's in 3 places, oxygen is in 4 places. So I'm going to look at the hydrogens. 3 times 2 is 6, and 2 times 3 is 6. 6 plus 6 is 12. No hydrogens here. I need something times 2 equals 12. I need to put in a 6. Now I have to cross my fingers and hope that the oxygens are balanced. 2 oxygens times 3 is 6 oxygens there. 2 times 4 is 8. So 6 and 8 is 14 oxygens to the left. 4 times 2 is 8. There's a 6. 6 and 8 is 14. They are all balanced. So that one is all hunky and dory. Next one, another one very much like the last one. You see oxygen all over the place, so we're not going to worry about that. Hydrogen's not so bad this time. We see 2 irons there and 2 irons there, so we're not going to worry about that. We see 3 carbons here, and we see 1 carbon there, and we see 3 sulfurs there and 1 sulfur there. So we're going to start by balancing out carbons and sulfurs. Whoops, got to backtrack there. Anyways, ignore that crazy 2 down there. How did that get in there? So, what have we got here? We have to check that our oxygens are balanced. We have 3 times 3 is 9. 3 times 4 is 12. 12 and 9 is 21. 3 times 4 is 12. 12 plus 3 oxygens is 15. 3 times 2 is 6, 21. So we know that all of the hydrogens, the oxygens, the sulfurs, and which carbons are balanced now. The last beast, you might have got a peek at that already. This one looks really foul. We have oxygen 1, 2, 3, 4 places. We've got hydrogen in 3 places. Let's check out their sulfurs. So we have 1 sulfur, 1 sulfur. And we see we have 2 sodiums, 2 sodiums. So it does tell us whatever number's here will be the same as that. Otherwise the sodiums can't be balanced. We have 2 nitrogens here, so that's why we have to pop in a 2 right here. Now we have to do a little finger crossing. Right here I see 4 times 2 is 8 for the hydrogens. Here I see 2 hydrogens. 2 times 3 is 6. 6 and 2 is 8. The oxygens, I have 4 oxygens here and 1 is 5 to the left of the arrow. 4 plus 1 is 5 to the right of the arrow. So element by element, when you balance equations, it's usually 1 element at a time is the safest way to go. You now have a range of 15 examples. That was exhausting for me. You have to do some thinking. You've got to do some practice. And that's why we have lots of fun-filled sheets for you. Enjoy.